right, problem number 2. In year n, the 300th day of the year is a Tuesday. In year n plus 1, the 200th day of the year is a Tuesday. On what day of the week did the 100th day of year n minus 1 occur? Oh boy. This is a hard problem. And so if you got this one, that's you're doing great. Let me give you a hint. And my hint to you would be to look at this on a timeline. Okay, so I'm going to draw a timeline here across the screen. All right. And I'm going to say day 1 of year n minus 1 occurs right here. Okay, so that's day 1 of n minus 1 of the year n minus 1. And let's say this is the year n. So this is day 1 of year n. Okay. And then, so let's say this is the first day of the year n plus 1. Okay. And let's just write down what we know and put it on the on this timeline. Okay. So we know that the 300th day of year n is a Tuesday. So let's put this is year day 300, and we know it's a Tuesday. Okay. And we also know that the 200th day, let's stick that about here, of year n plus 1 is a Tuesday. Okay. And we're trying to find the day of the week on which the 100th day of year n minus 1 occurs. Okay, so that's what we're looking for. And my hint to you, another hint to you, besides drawing the timeline, is to convert all these days, you know, the 100th day, the 300th day, the 200th day, let's measure them, instead of measuring them with respect to the first day of their respective years, let's measure them all with respect to the first day of year n minus 1. So we get one continuous set of days across here, and we're counting them all from one reference point, which is day 1 of year n minus 1. Okay, so that means this is still day 100, okay, with respect to the first day of year n minus 1. And we know the first day of year n then, it has to be 366, right? Because 365 was December 31st of year n minus 1, so the first day of year n is 366. Okay, so and I'm assuming too that I guess I'm going to assume, at least first of all, that there's no leap year, that none of these are leap years. Although I do know that it is very likely that one of these is a leap year. So if a leap year occurs every 4 years, roughly, then, you know, here we have 3 consecutive years. So there's a good chance that one of these is a leap year. So, but just to get us started, I'm going to assume there's no leap year. But we need to keep it in the back of our minds, okay, that one of these could be a leap year. But we'll just simplify things to start out with, okay? So day 300 of year n, if we measure it from day 1 of year n minus 1, is going to be 665, right? And then the first day of year n plus 1 is going to be 731. And the way I got that is I know that the last day of year n plus 1, or sorry, the last day of year n is 2 years out from the first day of year n minus 1, and I know there's 365 days a year, so this has to be 730. December 31st of year n is to be 730 when we measure it with respect to the first day of year n minus 1. So the first day of year n plus 1 has to be 731. And then day 200 of year n plus 1 then would have to be 930, okay, assuming no leap year. All right, so that will help. And the other thing that we know is that, the days of the week just cycle around every 7 days, right? So if this is a Tuesday and this is a Tuesday, we have to have some whole number multiple of weeks between these two days, these two dates, okay? So let's see what we get. Let's see how many weeks have passed since day 1 of year n minus 1 up to day 300 of n minus 1. Okay, so if we take 665 and we divide it by 7, then let's see, 63, 35, 5, 35, and you can see that here we have a remainder of 0. Remainder of 0. Kind of running into things here, but so it looks like that when we have if we have a remainder of 0, then it's a Tuesday, okay? Because when we divide numbers by 7, the remainders will also cycle, okay, right? Because they'll cycle from 0 up to 6 and then go back to 0 again as the number we're dividing gets bigger, right? So it would seem like if this is a Tuesday, and let's say that these aren't leap years, then it would look like day 1 of the year n minus 1 would be a Wednesday. And I say that because, if day 0 here would be like the last day of year n minus 2, right? So day 1, if we divide 1 by 7, we get a remainder of 1, right? So my thinking is, let me write it out this way: Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, Monday, Tuesday. Okay, so we get a remainder of 0 in this case for day 665. So the next day, if this was 666 and divided by 7, we get a remainder of 1. Okay, so if we get a remainder of 1, it's a Wednesday, and Thursday would be a remainder of 2, Friday would be a remainder of 3, 4, 5, 6, and 7. Although if we get a remainder of 7, and we're dividing by 7, then that's really a remainder of 0 again, right? So we can look at the remainders and tell what day of the week it is, okay? So, but we need to, we got in the back of our mind that we could have a leap year in here. So we've got two dates that are both Tuesdays, and so if they both have a remainder of 0, then we know we don't have a leap year, okay? Because we assume that there was no leap year, and if it works out, then it's true that there is no leap year between these dates. So let's check this. Let's check this this one. So here we have 930, and if we want to figure out how many weeks have passed since the year n minus first day of year n minus 1, we can divide it by 7. So let's see, 1, 7, 23, 3, 21, 2, 2, 14, and it looks like we get a remainder of 6. So that's an issue, because here it was a Tuesday and we got a remainder of 0. And here it's a Tuesday, we're told it's a Tuesday, but we get a remainder of 6. So there's an inconsistency here. So we also know if we had one more, if this was 931, then we'd get a remainder of 0, right? So it would make more sense if this was 931, okay? So we know there's got to be an extra day in here somewhere between the 300th day of year n and the 200th day of year n plus 1, and we know that leap years, the extra day is put into February, which is somewhere around the 60th day of the year. So it's before. So this had to be a leap year. Oops, leap year. Okay. All right. So we figured out there is a leap year, and we know that if year n+1 is a leap year, then these 2 years can't be leap years because leap years occur every 4 years, and so um, we're going to assume that n and n-1, those years are not leap years. Okay? Alright, so we've got it all worked out now. So now we have all of our dates referenced back to year n-1, day 1. Okay? So now we can just work through it. And and we can work by these remainders. So now if we take day 100 and we divide it by 7, we should just be able to look at the remainder and tell what day of the week it was. So let's take this 7, 30, let's see, 4, 28, 2, and we have a remainder of 2. So that would tell us that from that we've gone through 14 full weeks of this year n-1 plus 2 days, and so 2 days would put us at Thursday. So that is our answer. Thursday is the day of the week that it's the day of the week for the 100th day of year n-1. Okay? Does that make sense? So the key here was, first of all, to write out this timeline and then convert all of these dates, these 300th day and 200th day of the respective years, to convert them measure them with respect to the first day of year n-1. Okay? And that makes one continuous, we're counting continuously from that day 1 of year n-1. And that makes it a lot easier. And then just keep in mind that, the days of the week cycle every 7 days. So, so then we can look at the remainders and tell where we are in the week when we divide the days by 7. And we took into account the leap year here too. We found out that these seem to be inconsistent, so we needed an extra day in there to make them consistent, so they had the same remainders. Okay, and so that established our days of the week. We got a correspondence between the days of the weeks and the remainders, and then all we have to do is find out how many weeks have passed since the beginning of the year and find out what the remainder is, and that'll tell us what day of the week it is. All right, so that's a tricky one, but you see these problems. The more you see these problems, the more you work with them. It looks like a hard problem the first time you see it, but then when you see problems that are similar, and you're like, oh, okay, I've seen problems like this before. Let's see, what did I do on that other problem? And so you kind of learn the tricks as you go along, the more you practice. So there you go.